Today we're going to take a deeper look into loops and start looking at functions. They're quite similar in how they're used for programmers in terms they're both used to minimize the amount of code you have to write, but you'd use them in very different circumstances. We've looked at loops before where I said that you use a loop to basically do the same amount, just run a piece of code over and over again. And you do, and functions are used for the same. However, a loop is hard coded into, say, a script, whereas a function is a separate object that can be called. So if we look in MatLab here at this script here, this whole thing is a script, but majority of it is this function here, this function runway. When it stops, there we go, that gets called in this line here. This line here calls this function runway. And we'll come back and take a look at that in a minute. To begin with, what we're going to do is we're going to write a program that calculates, or a script that calculates the square root of a number, not just by using the square root command, but actually by mathematically calculates the square root of it using the iterative method here. It's basically a sequence, and we can code that. It's not very hard to code. So let's begin. First of all, we need to think about what the variables we're going to need. Well, we need a number that we want the square root of, and the square root, and also we want to know how accurate we're going to be. So because this is essentially a never-ending sequence, it's a converging sequence. We don't want it to just run forever, because it will run forever. We want it to eventually be a point where we're like, this is accurate enough. Okay, and so we'll just call that the error. So what is x going to be? Well, x can be anything the user wants it to be. So if we just put x equals input, and then we have some text here that tells us what we want, what we want it to be. So there we go. So very simple. What we're saying in this line here is that the variable x is equal to a user input, and then that text is displayed in the command window, which is down here. If I draw up, it'll be displayed in this line here, and it will, when it says that, we'll put, say, 5 in, and x will then become equal to 5. The square root is just a variable that we're going to use it in this method. We're going to basically update it every time. We're going to need a starting value though, because in the loop that will come on to show you that we use to calculate the square root, there needs to be a starting point for it, because the loop's going to run dependent on the error, which it will become clear what I'm saying in a minute. So we're going to need to calculate an error first, so therefore we just need to have a value. So we're just going to put it at 1 to begin with. And again, the error needs a value as well, so we'll just put that as 1 as well. So the first thing we need to work out is we need to make sure that the square root, the number we want to square root, is in fact positive, because if it's negative, we won't be able to get an answer. So we should have an if statement, and now obviously it's an if statement, so it needs a condition. If what? So if x is less than or equal to 0, do this. And what we'll do is we'll just say put some text out that says, sorry, we can't. that's all, and then it will just basically, you'll see in a minute, it will end it. So if, and then if that's not the case, you want something else to happen. Now what you can do is here you could put if x is greater than or equal greater than 0, do the loop, else output that, but it doesn't really matter, you can do it either way. Else, well, we'll put that code in a minute. And now this ends, close that all off. Now we need to work out how we're going to go about calculating this square root. So I said earlier that we'd use a loop, and that's because if you look at this block of code here, we're going to be running essentially this code over and over again, this sequence where xn is updated every run of the loop, and then we use that xn in the next run of the loop to work out the next step. A bit like how last lesson we used I as a counter, and then we used the current value of I to work out which box in the array we're looking at. In this one, we're going to be using the updated value in the next run of the sequence. If you're unfamiliar with converging sequences, this might be a bit more difficult for you to understand. It might be worth going away just googling converging sequences, but then you will see what's going on here. Okay, so first of all, let's start the loop. So we're going to use a while loop again. You can use for loop. They basically do the same thing. Now we're saying while it's a loop. The loop needs a condition. While what? If we just put while, and then some code, which I've seen quite a few times, you've got to really think about what this code is actually saying. We've put a while loop here, and if we just put some code here that said, I don't know, I equals I plus 1 like we had last week, plus or minus, what's this actually saying? This is saying while nothing, I equals I plus 1. There's no condition here. If this doesn't make sense in English, you've got to have some kind of condition there. So in our case, we're going to use the error, because remember, we're working out the square root of something, and we want the error to be of a certain size. So we're just going to put error is greater than, and we'll just put something really small like that. No, I think it was 6 zeros we're using then. While that is the case, it was 5 zeros. Then this loop runs. Okay. Now what's actually going to happen in this loop? If we go back here, we basically need to create this formula in the code. Xn plus 1, we're just going to call square root so we can minimize the amount of variables we need. But if you also look at this, we've got x because that's the known number. We know what that is. But xn is another variable we're going to have to create. Now, where are we going to start with xn? In this case, we're just going to start with 1. But we're going to need to declare this outside, otherwise it's going to keep redeclaring it. Xn equals 1. That's basically the starting point of this loop. You can really start with anything. I've written this program before, and I've tried it with where the xn is an input value, and if xn is an inputted value, you'll find out that no matter where you really start, you'll find the sequence always comes back to the same answer. It just might take a different number of runs. But we're just going to start with xn equals 1. So let's start building this code. So square root equals 0.5 times xn plus x over xn. Just make sure that is correct. Yes, it is. Okay, so that is. I've got too many brackets there. No, yes, I have. Oh, no. What's going on here? Oh, there we go. Okay, so as you can see, so square root is equals to this. Now we need to calculate the absolute error or update the error here, because if we don't update the error, what it's going to do is, while error is less than this, okay, the error is less than that, so I'll run it. So I'm just going to move this because it's actually annoying me. Put it up at the top and keep things nice and neat. Okay, so while the error is greater than this, run this. Now if we don't update the error, it's going to run this once, okay, run that piece of code, and then just keep doing it, because it's just going to run that same bit of code over and over and over and over and over and over again, which means you'll get stuck in an infinite loop. So we need to update the error. So now equals, now if we remember from here, it's the modulus of the xn plus 1, which in our case is square root, minus xm. In MATLAB, modulus is something very easy. It's just abs bracket the actual formula. So in our case, xn, and then another semicolon there. This means it's going to update the error. Now, if you look at this and we run it quite a few times, what's going to happen is we're not actually updating, because if you look at this code, xn plus 1 here needs to be updated. We need to set it as moving along every time in the sequence. So down here, we just need to put xn now equals square root, because then next time it runs it, it's going to use the value we've just worked out in this formula here. So that's that loop finished, really. That's got all the code we need in there. Once it's finished this loop, we need it to spit out the answer. So if we come down here, we need to have it display square root. So we can now give this a test. Now we're running it. Let's see. Let's try a number we know. Well, we know 100 square root, that's 10. There we go. Let's see if we run this again. 16. There we go. And if we run it again, let's try a number we don't necessarily know the square root to 20,574. I don't know the square root of that number, but if we just copy this here, square root of is 143 point. Basically, we got exactly the same answer. So I think it's out by, yeah. So we stop there because the error we calculate is acceptable. But there we go. Basically, we're getting the right answer. So that's that code run, and that's more information on loops. As I said, it's when we run this run the same piece of code that we're going to need to do it loads of times in quick succession. Now let's move on to functions. What happens if we want to embed this piece of code in a massive script, for example? Any good example of where you might use a function is, say we've got a script that we give it some information about a car, and depending on certain bits of that information, it does certain things. So we might say, if the car is blue, do this with it, or sort it somewhere, and if the car is red, sort it somewhere. So in the main script, you might have a loop that goes through all the data that's been inputted. So you've got an array of 20 boxes or columns. It's going to go through that array, every column, and do something with it, depending on what it is. So you might have in that while loop that goes down, so while the data in that box is something, that's a condition we can look at in the future, but let's say while I is less than 20, it's going to go through that array, take every bit of information in there and do something. Then you'd have an if statement in there, and in that if statement it would say, if the car is red, do this, if the car is blue, do this. Instead of just putting all that information in those if statements, it can start to look a bit messy and clutter up your main piece of code, and you don't necessarily want that. So you develop functions, and those functions are either separate MATLAB files, which you call, or at the bottom of the script, and they then do something with that number that we've or that value that's taken. So you could have a function called red car, and it will do something. And that way, it's very easy to look at the top piece of code, and it's very easy to look at the top piece of code and see what's going on without it being full of other stuff. So let's start changing this script into a script that uses functions instead, a very basic level, and we'll go from there. So in this case, we want x is to be still there. We're just going to get rid of this line of code now, and we need to stipulate some outputs that we want from this function. So we start off with some square brackets, and we are going to need, in those square brackets, we need some outputs that we want to gather from the gather from the function. In this case, we're just going to leave them blank because we don't actually need any outputs. The function is going to do everything we want for it, but I'll show you what you do if in the next bit if you want some outputs from it. And now we go equals, and we have the function name, so we're going to call it negative because the value is negative, and we need some inputs we want. In this case, we don't want the inputs because we're not actually going to do any maths or anything in the function. Now let's go about writing this function. Function, and don't want anything, equals negative and end. We might have to just get rid of this. There we go. So this is just going to call the function negative without any outputs. So in here, we're just going to put the same thing we wrote earlier. So I think we wrote something else up, but it doesn't matter. Now we've got this function here that, see how it's a lot easier to read this. Well, I mean, it's the same. In this case, it is adding more work, but going forward, say there was a lot more code, so there's 20 lines under there, we'd just write negative. Oh, hang on, we can go and find out what that is. Here we're going to just copy and paste all of this because it saves us writing it out again later. Now we need some outputs because we want to output the square root. So we want square root as an output equals positive, yeah, that's how you spell it. And we need some inputs for this function. What values does this function need to perform what it's going to do? Well, it's going to need x, the input. It's going to need square root, I guess, because we start calling it 1 to begin with. Although in this case, we could actually just remove this here and then put it down in the function to save some space, and I think we'll do that. Again, the same with xn, and the same with error. If we were giving xn as an inputted value, then we could put that in here. We could put xn here and pass it through. So now we need to write the function, and we need square root equals positive x. Now those values, now we can just copy and paste that loop from earlier in. We just need to indent it to make our code look nice. There we go. So as you can see, we're getting an error here, or because that variable error isn't declared inside this function. So error, again, we'll just say 1, xn equals 1. And then square root we can actually work out in this function here. We don't need to update it. So now this piece of code here is going to, if it's positive, it's going to call this function x, and the function x is going to output the square root. The square root is then going to get displayed, and you'll see this by if I run the code now and put 100 in again, 10 gets outputted again. Now you don't always, in this here I've called the values the same thing, but that doesn't have to be the case. If I change this value here to example, and then this value here to y, and I run the same bit of code again, I put 16 in, again it outputs the value. Now what this is doing here is, this line here is where we stipulate what we're going to call the inputs and outputs in this section of code. So we want to input to this function the variable x. If we were to input another one, let's call it example2, we'd also need to stipulate that input down here. And we could give it, again, any name, but that variable has to have something here. So we can say, just call it pass-through. And then that variable is giving me underlined because it's not being used. But this here, example2, if we had a variable example2 equals 1 up here, it'd pass through, and this function would have the value of 1. But we can get rid of that. And that. And the same here. So in this function, we say we want whatever is outputted from this function that we're calling. So whichever variable is outputted from the function positive, we want to call it square root. I often use the same variable names in both parts of the script just because it makes my life easier reading it. I know what all the variables are actually called, but you can call them whatever you want. Now this is really quite a primitive use of functions that you probably you'd never use them in such a simple argument, because you'd actually probably put all of this as one function. What's the square root of a number? And then if it's negative, you'd output that you can't do it. A better example of where you'd use functions is in this script here. This script is all about working out when something takes off, when a rocket-powered glider takes off, and its speed when it takes off. And we've got a function here called runway, which does all the maths for us. These are the variables we're passing through. These are the variables we're outputting. The outputted variables are then used in this bit of script here to plot the graph. The inputted variables all used in this function here. And you see, this is, if this script was a lot longer, and we then started to look at the in-flight functions or the in-flight behavior of the glider, what we'd then use is we might have another function down here called in-flight, and that would use the speed at takeoff and the time at takeoff to work out the air resistance and things, and then we'd use that to plot something else. And that way we can have a nice simple script that is very easy to read exactly what the script is doing from here, because we can go, oh, hang on, it's working out what's happening on the runway, and if there's another line in flight, it's working out what's happening in flight, without actually knowing exactly what those functions are doing. It's much easier and neater way of laying it out. And this is the beginning of object-oriented programming. A function is essentially an object. It's something that we can call at any point, and it will behave in exactly the same way. Enjoyed this, please like and subscribe, leave a comment and perhaps what you'd like me to see me explain in the next video, and hit that notification bell. Cheers, bye.